I'm going to talk about the main OpenMP 3.0 features, and I'm wondering how many people in the audience are familiar with OpenMP? Oh, excellent. Actually, Carl mentioned OpenMP a bit just before we started, so the outline is as follows. First, I'll give an introduction of OpenMP, talk about the main features in OpenMP 3.0, what are our plans in Sun Studio, and point you to a number of useful resources. So what is OpenMP? Most of you know it's the de facto standard API for shared memory parallel programming in C, C++, and Fortran. And it consists of three things: compiler directives, runtime routines, and environment variables. The specification is maintained by the OpenMP Architecture Review Board. This is like a standards committee for OpenMP. The last released specification is version 2.5, and now we have a draft specification, version 3.0, that's available for public comment. So I would encourage you all to look at that and give your comments if you have any comments on that. So here's the main directive in OpenMP that is essential for parallelism, because this parallel directive is a directive that creates threads. So in C or C++, you would have your code, enclose that by a parallel directive, as you can see there. In Fortran, you need a parallel and parallel directive. And that means that the code enclosed by that directive will be executed by multiple threads. Oh, great, thank you. So as you can see here, the fork join model. When you come to a parallel region, this initial master thread will spawn a team of other threads, and the master as well as the team, the master will be one of the threads in the team. All the threads will execute the parallel region. At the end of the parallel region, there's a barrier, and only the master thread will continue. Several advantages for OpenMP. It's straightforward to write multi-threaded programs, requires little coding effort, allows you to do incremental parallelization, pure sequential program, widely supported, and there are lots of directives to express parallelism. So I'll give you an overview, a brief overview of OpenMP Specification 3.0. The language committee meeting started in September 2005. Actually, there are several members here in the audience, members of the language committee. And it was started with about 50 issues to be considered for the new specification, but only the following issues remained. And the timeline is as follows. In October 2007, a draft OpenMP 3.0 specification was released for public comment, and the public comment period will go on till January 2008. So try and get in your comments before January if you can. In spring 2008, the specification will be finalized and released as a final specification, 3.0 specification. So So let me give you an example of the sort of things that were being tackled in specification 3.0. Here's an example of a while loop. And as you can see, we have a pointer P that's used to traverse the elements of a linked list. And as long as P is not null, we do work on whatever P is pointing at, and then we go on to the next pointer P. Now, this was hard to parallelize in specification 2.5 because what you needed to do, for example, you had to first count the number of iterations and then convert the while loop to a do loop or a for loop and then parallelize that. So that was not very easy to parallelize in 2.5. So what was introduced in 3.0 is tasking. And this is the biggest addition for 3.0. It's worked on by a separate subcommittee that re-examined the issue from the ground up. And tasking allows parallelization of units of work that are dynamically generated. It provides a flexible model for irregular parallelism and new opportunities for parallelization, like parallelization of while loops and recursive structures. So when you're using tasking, conceptually there's what you could call a task pool that's associated with a parallel region. So if you start a parallel region and you define your tasks in that parallel region, then conceptually each of these tasks is thrown into some kind of pool, and then the threads in the team will be picking tasks out of that pool and executing them. Couple of directives that I'd like to mention here. There's the task directive that allows you to define where your task code is, and a synchronization directive, the task wait directive. This task wait enables the current task to suspend execution until all the children tasks generated in this current task up to this point are complete. So it's a way of waiting for other tasks to complete. So these are essentially the two directives. The task directive to define a task and task wait, and these were added to support tasking in 3.0. Tasks are complete at an implicit thread barrier or an explicit thread barrier or at a task barrier. So I'll go back to that example we had where we had that while loop, and now with the task directive, what you could do, so here's our parallel region that spawns a team of threads, and inside the parallel region you have one thread only traversing the list. That's why we have the single directive, so only one thread is actually doing the traversal, and then each time that thread encounters a valid pointer P, it defines a task of do work on P. So that's going to be a task that's thrown into a task pool, and one of the threads in the team is going to pick that task and execute the work. And the threads, or the tasks rather, are guaranteed to complete at the implicit barrier here, the first implicit barrier. So that was a general overview of tasking. I'll go over some other additions in 3.0. Two environment variables were added, OMP stack size to control the stack size for the threads, OMP wait policy. This one was added to hint what do you want the waiting threads to do. Do you want them to be active, mostly spinning, or do you want them to be passive, mostly sleeping as they're waiting? Schedule runtime is now more useful. You can actually set it and get it via runtime calls, not just an environment variable. And a new schedule kind was added, the auto schedule kind. So you can have your parallel do loop, for example, and say my schedule is auto. And what this does is it gives the implementation full freedom to decide how to schedule the iterations onto the threads. One more addition in 3.0 is random access iterator loops can now be parallelized. So for example, this is a for loop, and you have an iterator IT, random access iterator, as your loop index. This kind of loop can now be parallelized. In C++, Threadprivate objects, how they're constructed and destructed has been clarified. And in addition, C++ static class members can be Threadprivate. So here you have a static class member, I, and you can say Threadprivate I. There's a missing parentheses. Another thing in 3.0 is the collapse clause that you can add onto a loop. This one tells the compiler how many loops should be collapsed together first. So the compiler would collapse those loops together and then parallelize the resulting loop. In Fortran, allocatable arrays now can be privatized, and you can have their status to be currently allocated and be able to privatize them. In 2.5, you couldn't do that if their status was currently allocated. So now in Fortran, you can allocate the array here and then say private A. That will be allowed in 3.0. Nesting support, there's much better support for nested parallelism in this 3.0 specification. So what we have now is per task internal control variables. So you can actually call OMP setnum threads inside a parallel region and control the team size for the next level of parallelism. This was not possible in 2.5. So now we know exactly how these runtime calls will behave and how nested parallelism would behave in 3.0. Then we have new routines to determine the depth of nesting, the IDs of the parent and grandparent threads, and the team sizes of parent and grandparent teams. So a number of useful runtime routines for getting information about the program. In addition, there are routines that allow you to control nesting. So you can, for example, control how many levels of nesting you have via an environment variable or runtime call. Also get that level, get the maximum level via runtime call. Then there's also a new environment variable and runtime routine to set and get the maximum number of OpenMP threads available in the program. So that gives you an overview of what 3.0 is about. Lots of new stuff in there. As far as Sun Studio is concerned, the plan is to make Sun Studio, the next Sun Studio release, fully OpenMP 3.0 compliant. And our initial target date for the implementation, for an initial implementation, is Sun Studio Express 2, which is scheduled sometime in second quarter of 2008. And beyond that, we will add support for 3.0 in the various tools, GBX, Thread Analyzer, Performance Analyzer, and so on. And if you need to look at useful resources, best place to go is to check out the new specification. This is a direct link. You can get to it through the OpenMP website as well. There's a forum. So if you have any feedback, any questions, anything you want to comment on or ask about, you can post it on the forum, or you could send email to the feedback email alias.